The next lesson for Unit 7 is 7.5, Parallel Pictures and Angle Measures. So what we're going to be doing today is taking into account the angle relationships and stuff that we saw with the previous lesson and those angle clumps that we actually saw when we grouped the angles that were formed by the sets of parallel lines and the transversal. What we're going to do is we're going to actually be angle clumping, and then we're going to be sliding them. So kind of like how we talked about corresponding angles in the last lesson with going down the zip line, the transversal being our zip line, we're going to actually use that transversal line to be our zip line and slide the whole set of angles. So what I'm going to have us do here is just kind of take a little bit of a focus on the top part here. So I'm just going to look at angles 1, 2, 3, and 4, which is a pretty easy picture for us to look at. We have vertical angles, we have linear pairs here. And it tells us in this one, the measure of angle 1 is 108 degrees. So I'm going to find angle 1, and I'm going to go ahead and label that as 108 degrees. It says to find the other angles, and then we're going to go back and clump. So if I'm looking at these, vertical angles are the ones that are across from each other, which tells me that angle 4 would then also be 108 degrees. You want to take special note and care to make sure that you're labeling these in your notes packet so that you can follow along with this one. If I focus just on angles 1 and 2, they create a linear pair for me. So in order to find angle 2, I would be doing 180 minus that 108, which is already there. That's going to give me 72 degrees remaining. So that tells me that angle 2 is 72 degrees. Because angle 2 is vertical to angle 3, I also know that angle 3 is 72 degrees, which makes sense because 1 and 3 are linear pairs, and 3 and 4 are also linear pairs. So this angle clump has pretty much worked out. So what I'm going to ask you to do is to go ahead and actually clump up your angles. And what we're going to do is we're going to take these angles and we're going to actually just kind of duplicate them here. So I am going to try, and sometimes this works, sometimes it doesn't because it doesn't like this picture here. It looks like it's not going to let me select these, not easily at least. So we're going to have to do a little bit of work here. So I'm going to go ahead and I'm going to group these all together and I'm going to actually duplicate them. And in doing so, I'm going to take this clump and I'm going to slide it right on down the transversal. You can kind of see the outline there. I'm going to go ahead and set that right there. So the cool part is we can know that there's different angle relationships here, but once we can actually fill in one of the clumps of angles, we can actually slide the entire set down. This is going to help us with some little bit more complicated problems kind of moving forward here. So when you're working with parallel lines, you're going to fill in the one clump as much as you can, and then you're going to slide it down to the other clump and just kind of just copy and paste basically, just right on top of there. So take a second here if you need to pause the video so that you can fill this in. You might want to also make yourself a note here. Oops, I gotta select my pen again. That here we just did the angle slide then. And it's literally a duplicate copy down here. This only works though if these are parallel lines. If they are not parallel lines, those angles are not going to match up properly. They still have the angle relationships, the alternate interior, exterior, same sides and stuff like that, but they are lacking in terms of what the measurements would be. So this is only true if you have parallel lines. In example number 2, 3, and 4 here, we're going to be doing some sliding, and I'm going to allow you to be able to solve for an x. So you might need to kind of tilt your head just a little bit here. I'm going to go ahead and actually just fill this clump up, the first part here. And then what I want to do is I actually want to clump up down here as well. And I'm noticing that this X is down here. Instead of filling in this whole entire clump and then doing the whole entire thing, because I only need to find that one spot, I'm going to actually just clump and I'm going to just slide right down. So if I look at my clump here, if I were to take this with the 91 and then I were to go and actually just slide that down, notice that that 91 is going to be right in that spot when you actually did the angle slide. That would tell me that X and 91 are going to actually end up being a linear pair here. So to get X, I would have to do 180 minus 91, and that's going to give me 89 degrees. When I'm asking you for the relationship, I'm just asking you to practice your vocab terms. These are both on the interior of the parallel lines, and they're on the same side of the transversal. So we would call these same side interior. We probably should have started there, but that's okay. We'll start there on example number 3. When I look at the 53 and the x, these are both located on the interior. They're inside the parallel lines, but notice that they flipped over the transversal. So we call this alternate interior. And you're welcome to shorten those in whatever way makes sense to you. Again, we're going to go ahead and clump right here, and we're going to clump down here. And if I were to do the angle slide down the transversal, that 53 is kind of what I would call the bottom left when I'm looking at this group. So if I have my 53 here in my clump, and then I go ahead and I grab that and I slide it on down, that 53 is going to go right there. The 53 and the x are actually now vertical angles because they're across from each other. So without doing much work, I know vertical angles are equal to each other. So x would also be 53 degrees. For example number 4 here, I have the 88 and the x. Those are alternate exterior angles. Again, I'm going to go ahead and do my clumping. That's right here. I'm going to take my 88, which is in the top left, and I'm going to go ahead and slide that on down. And when I put it into the clump, top left is across from the x vertically across. Vertical angles are equal to each other, so x is equal to 88 degrees then. Taking a look at example number 5, we're going to call these guys the same side exterior. And clumping these, when I move that x down, the x is going to come right here. Noticing these two form a straight line together, so I'm going to have 180 minus 73, and that is going to give me 107 degrees for x. Over here, this next one, they're really, they're in the same clump, so that's a little bit different. What this means is we can pretty much ignore the bottom clump and just look at the relationship. Are they vertical or linear pair? So these are actually just straight up a linear pair. And hopefully you've noticed all along in this lesson that the only two relationships that exist here is either vertical or linear pair once you do that slide. So a linear pair would tell me that they have to add up and give you 180 degrees. So this one I actually do have to do a little bit of solving work, which is good. It's getting us ready for our next lesson here. So 78 plus 42 is going to give me 120, plus the x is equal to 180. Subtracting away your 120 on both sides, you're going to get x is equal to 60. Always remember, unless you're doing like a class kick or something where you're typing in your answers, anytime you're writing in your notes, you should always have that degree symbol that's on there. The class kick, it's not easy to put that in because it's actually a superscript. So when you do the class kick, I will just ask you to type in just the number part. Example number 7, my parallel lines are up and down this time, which is a little bit different. So I'm going to go ahead and take a look at these two right here. This 74 is in the top left, and if I move it over here, it actually goes right on top of the x. So the x is also going to be 74 degrees, and because they're in the same spot, our relationship here is called corresponding. And the last one here, so if we take a look at this, if we clump and clump, I can move that 60 down, or the other thing, we can actually slide up if we really wanted to. The x would go right down here, so x is going to be 60 degrees, and those are alternate exterior angles then. So that's 7 and 8 for you. And that is it for lesson 7.5 then, talking about those parallel lines, doing the angle clump and the angle slide.